All right, let's take a look at section 7.5, properties of trapezoids and kites. We are looking at the last section of the chapter, and let's get started. We'll start off right here by taking a look at the flow chart, the properties of quadrilaterals, and now we're going to go ahead and begin to look at the right-hand side. We've got two things. We've got the kite, and then we also have the trapezoid right here as well. So those two, they're split apart because they have two separate types of, they don't have similar characteristics other than the fact that they're four sides. And then as we go deeper down into the trapezoid, we look at the properties of an isosceles trapezoid, which has some characteristics of like an isosceles triangle in the fact that two sides are going to be congruent, those two sides being the legs. So let's go ahead and get deeper down into this. So we'll take a look now at some of the properties and characteristics of starting off with the trapezoid. I'd say the basic one right here is that a trapezoid is a quadrilateral with one pair of parallel sides. So you can see right there I have a diagram of a trapezoid, and the bases we'll go ahead and say are the two sides that happen to be parallel with each other. So right now, and highlighted in blue, those would be the bases. Now the base angle, I would go ahead and represent that as the two angles that I'm showing you right there. So those are going to be your base angles. So let's go ahead and put base angle, base angle. We have the top and the bottom are the bases, and then I'll go ahead and put right here in red, those would be your legs. So the difference between a trapezoid and an isosceles trapezoid is that those two legs that I have there in red would be congruent to one another. We can go ahead and move on next and take a look at a kite. Well, how about the mid-segment of a trapezoid? And so the mid-segment of a trapezoid would be when you take the midpoint of two legs, or both of the legs, and you're going to draw a line that connects the two midpoints. And that would be this would be right here, your mid-segment. Just like that. Next up, let's take a look at the kite. So I've listed three things about a kite. Okay, some of these properties, and we'll take a look at some of them. We'll revisit it later in the lectures. First off, a quadrilateral that has two pairs of consecutive congruent sides. Okay, so not just one pair of sides, but two pairs. The two consecutive right here, hopefully if you look at this, you'll notice that if I just look on the left-hand side, the top and bottom segments, they're not the same. Okay, so it's going to be the two segments up on the top part of the kite, and then the two segments on the bottom half of the kite would be the congruent parts. The diagonals are perpendicular. So if we were to draw a diagonal from, let's go ahead and put this up a little bit higher. But if I go draw with the dotted line, I'm drawing my diagonals. It is saying that right here, when these diagonals intersect, you've got a right angle. So diagonals are perpendicular, and then lastly, it says one pair of opposite angles are congruent. And hopefully, you'll be able to visualize and visually notice that the opposite angles that are congruent are going to be the ones that happen to be on the, I guess you could say, like the obtuse angles that happen to be in the kite. So that would be the parts that happen to be congruent. And I went ahead and marked it there in gold. So those are some of your main properties of a kite right here. Let's go ahead and move on to some of these theorems to help us along with understanding the properties of a trapezoid. Let's start with theorem 7.14, the isosceles trapezoid base angles theorem. So, if a trapezoid is isosceles, then each pair of base angles are congruent. Now, we're dealing with two segments that are parallel. So, if you think about it, we have our parallel lines, and then what ends up happening right here is that the leg would be your transversal. And those two angles right here, angles A and angle B, in the diagram, those two would happen to be supplementary because they are consecutive interior angles. And consecutive interior angles, don't forget, are supplementary. So it makes sense right here that angles B and angle C to be congruent, and angles A and angles D are congruent. And those right there are the base angles. So let's go ahead and move on to theorem 7.15. We have the isosceles trapezoid base angles converse. Right here it says if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So one pair of base angles right there happens to be congruent, angles A and angle D. So it could also be angle B and angle C. Those could be congruent as well. So it says if one of those two, one of the pair of base angles are congruent, and the legs right here are congruent, because that makes it isosceles, then we have an isosceles trapezoid. Let's go ahead and move on to theorem 7.16. We have the isosceles trapezoids diagonal theorem. And remember, when it comes to diagonals of an isosceles or a trapezoid in general, right here, we don't really know anything. It's not like a kite where we said that, hey, the diagonals are perpendicular. In the isosceles trapezoid diagonals theorem, it says a trapezoid is an isosceles if and only if the diagonals are congruent. So that is what we need to know right here. A trapezoid is isosceles if and only if its diagonals are congruent. And that's what we'll know about the diagonals only in an isosceles trapezoid. Okay, in a regular trapezoid, that may not be the case, or your normal trapezoid. We got in theorem 7.17, the midsegment trapezoid midsegment theorem. It says the midsegment of a trapezoid is parallel to each base, and its segment is 1/2 the sum of the length of the bases. So if you look at the diagram right here, that midsegment is going to be equal. Okay, so the midsegment is MN. There's your midsegment, and that is equal to taking segment AB plus segment CD and then multiplying that by 1/2. So here's our equation right there. Make sure that is one that you should memorize. Okay, so the midsegment, or in this example, MN is equal to 1/2 AB plus CD. Next up, we have theorem 7.18. We're taking a look at the diagonals of a kite. So once again, right here, a quadrilateral is a kite if the diagonals are perpendicular. Let's go ahead and move right along. Theorem 7.19, the kite opposite angles theorem. Remember, there are one set of angles that are congruent. And typically, you should be able to see it. They're obtuse, the two angles that are obtuse right there. Okay? Only one pair, not all four. Otherwise, that would be a different type of figure. All right. So now we've got all of our different parts here. Let's take a look at some questions. So let's take a look at number 1. It says show that the quadrilateral vertices at Q, 0, 3. So let's go ahead and plot some points right here. At 0, 3, we have Q. We have R is at 0, 6. S is at negative 6, 0. And then T is at right here, negative 3. So we do have ourselves a trapezoid. Go ahead and finish my drawing right here. And then we want to decide whether the trapezoid is isosceles. So remember, if it's an isosceles trapezoid, then right here, the two legs, which would be R to Q and S to T, they must be congruent. Okay? So how are we going to figure out if they're congruent? There's only one thing we know is typically we could use the distance formula. Fortunately, right here, we can actually count things out. So I'll go ahead and put right here, if you cannot count the distance, use the distance formula on the legs. Okay, so luckily from R to Q, this is a length of 3, S to T is a length of 3. So then we can go ahead and decide that yes, this is an isosceles trapezoid. Okay, so we could say this is an isosceles trapezoid. So now the last thing it says, find the length of the mid-segment of the trapezoid. Well, in order to find the mid-segment of the trapezoid, remember, we have to find the length of the two bases, and then from there, use the equation of 1/2 of base 1 plus base 2. When it comes to finding the mid-segment, we'll take a look at a few problems later on. And I'll show you how to do that there. So let's go ahead and move on next to number 2. It says let's find the measure of angle K and angle L. All right, so let's see. If I have myself, looks like I have an isosceles trapezoid here. I've got two legs that are congruent, and I have the bases are parallel. So what I can go ahead and do right here is say, all right, this angle M, that right there should be congruent to angle L. Base angles are congruent. So angle L right here, that is equal to 23 degrees. And then we have ourselves next up, let's find angle K. Now with angle K, we have to remember that angles L and angles K right there, those two happen to be consecutive interior angles, which mean they add up to 180 degrees. So if I go ahead and make a calculation here, and I'll go ahead and make an equation, and hopefully you could think of what the equation will be. And if you're thinking that it's going to be angle 23, or L, 23 degrees, plus angle K is equal to 180, then you are correct. And then we can go ahead and subtract 23 to both sides and find that angle K ends up being equal to 157 degrees. So angle K is 157. And we go ahead and put together things that we learned from first semester to help us find these two angles. All right, with number 3, I take a look at this, and it looks a little different than number 2 as far as the shape and the type of figure that is. That's because number 3 right here, it happens to be a kite. Because take a look, I've got these consecutive sides, 2 pairs of consecutive sides that are congruent. I went ahead, I'll highlight JL is congruent to JK. And if you see right here, LM is congruent to KM. All right, so those are the consecutive sides that happen to be congruent right here. So let's see what happens next. What can we say? What can we do? Opposite angles should be congruent, so angles L and angle K should actually be the same. So these two angles right here are congruent, but we don't know what they are. But what did we learn in this chapter? If I have myself a quadrilateral, or actually in any polygon, a convex polygon, we could figure out how many degrees makes up the interior of that polygon. Well, if you remember the equation, or you actually memorized it, if you memorize it, great, because hopefully you're going to know that we see the quadrilaterals. We've done it quite a few times, but without doing 4 minus 2 times 180, or maybe you just remembered it, the interior angles of our polygon right here is going to be 360 degrees. Okay, this is the interior angles. So now what I could go ahead and do is come up with an equation. Because remember, I have two angles that are the same, L and K. So what if I go ahead and label those two angles X, because they're congruent, and then we can go ahead and come up with our answer. Here's my equation. We've got X plus 90, which is angle M, plus angle K, which is X, and plus angle J, which is 130 degrees. All those combined together, that's equal to 360. And it's amazing how we could just put all that together, right? It all works out nicely. And so I've got 2x plus, looks like 220. That's equal to 360. I'll subtract 220 to both sides. And I'll end up with 140. And then divide both sides by 2, and x is equal to 70. So that right there is the length of both angles K and L. They're both 70 degrees because, remember, L and K are opposite angles, and they're going to be the ones right here that happen to be congruent. It's not always. Remember, I did say earlier, hey, it's usually the obtuse angles that are congruent. It's not always the case, obviously, as you can see right here. So based on the information, we can gather that since this is a kite, that those two are the two congruent angles. Let's go ahead and move on next up to number 4. We find CD. Okay, so this is where we're going to get to that mid segment. So the mid segment right here is equal to 1/2, and then we got ourselves base 1 plus base 2. So we're trying to find CD, which happens to be your mid segment. So let's go ahead and put CD in the space where it says mid. And then I can go ahead, since I know what the bases are. One of them is 12. The other one is 36. Man, if you know the equation, that makes things a lot easier right here. And then we can go ahead and solve that out. So we take 1/2. 12 plus 36, that's 48. And half of 48 gets us CD, which equals to 24. And just like that, there you go. Next up, looking at number 5. I can see right here on number 5, the bases, the top DC and AB, they give us some information, but not all of it. Right? What's unknown is this D to C right here. We don't know what that base is, but we have our equation, right? And so if we put everything together in the equation, we should be in good shape. This time they give us the mid segment, it's 1.8. So let's take 1.8, which is the mid segment, and then set that equal to 1/2. Base 1, we don't know. That's C to D. I could also substitute that in with X, but I'm going to go ahead and put CD right here, and then it's going to be plus 0.6. And let's get our answer right here. So algebraically, it's a little bit more challenging. I would start off, let's get rid of this 1/2, and in order for us to do that, I've got to multiply both sides by 2. So 2 times 1/2, that ends up equaling 1. Now let's take a look at 2 times 1.8. And that right there, I have 3.6. And then we'll have CD plus 0.6. And then last thing we need to do right here to get CD by itself is we can go ahead and subtract 0.6 to both sides. And we'll end up with CD is equal to 3. There's the length of CD. All right, we're coming down to the end. We got 2 more questions as we take a look at number 6 next. On number 6 right here, we've got ourselves, looks like we've got ourselves a trapezoid, and we got to find X. Well, they give us 3 parts of the trapezoid, the 2 bases and the mid segment. So guess what? We're going to have to use that mid segment formula. And we'll just plug things in accordingly. We got 3x minus 2. That's the mid segment. That's equal to 1/2. We'll take base 1, x plus 11. And then we have plus base 2, 3x plus 3. And from there, what we should be able to do is, in red, we can go ahead and simplify everything that's in there and then work our way into solving the problem. I could multiply both sides by 2, similar to what I did in number 5 first, but I think right here we can go ahead and simplify this in red, and I've got 4x, and then I got plus 14. And luckily, right here, I could actually, instead of multiplying both sides by 2, I could distribute that 1/2. And why would I distribute the 1/2 is because when I look at what's in red, I could multiply all that stuff by 1/2 and get even numbers, or like nice whole numbers. It's like you end up dividing it all by 2. So that's why I'm going to go ahead right here, instead of multiplying both sides by 2, let me go ahead and just distribute the 1/2, and I'll end up with 2x plus 7. I'll get x by itself, subtract 2x to both sides. I'll have x, and then add 2 to both sides. X is equal to 9. And there you go. Now be very careful, because sometimes the questions may ask for you to find the actual length of a certain side, and you have to plug it in. But they're not asking for that right here, so all is well, and we found x. Lastly, let's take a look at number 7. So, in number 7 right here, there should be something we know about the diagonals, okay, to maybe help us out. Now, there might not be something that we learned specifically in this chapter that'll help us get our solution, but think about what we know about our diagonals right here. Okay, so we have our diagonals, and one of the things we learned about our diagonals is that they're perpendicular. Next up, take a look at G to H and G to F. We have two segments that happen to be congruent, okay, at one point on this perpendicular line. Well, if you remember, in chapter 6, we learned something about the perpendicular bisector theorem, or more specifically, the converse to the perpendicular bisector theorem. And from all of that information right there, what that tells me is that G to E is bisecting segment HF. And because GE is bisecting segment HF, I'll go ahead and delete some of this stuff right here. We can go ahead and say that J to H is congruent to F to J. And so therefore 1/10 x minus 1, that's equal to 9 right here. And then I go ahead and just solve for x. So once again, you got to remember some of the things that we've learned in the past. You can't forget. And so once again, this perpendicular bisector theorem, we learned that in chapter 6. So we get x by itself. I'll add 1 to both sides and end up with 1 over 10x is equal to 10. And in order for me to get rid of 1/10, we will multiply that by the reciprocal, which is 10. So let's multiply both sides by 10 right here, because that does some canceling out. And x is equal to 100. And there you go. We have found x. But in order to get to that information or get to our equation and solution, we had to realize a few things. First off, yes, some of the characteristics of a kite. Diagonals are perpendicular. But after that, like, look, I can't figure out a whole lot more. But because the converse of the perpendicular bisector theorem, we can go ahead and say that HG is congruent to FJ, and then set those segments to equal to one another. And there you have it, another chapter in the books.